My Chinese lathe has many problems, and some of them are tough to fix. In my last video I took a look at the saddle fit and tried to work out how to improve that, but it's going to require some serious work, some machining, and probably learning some new skills. Not all the problems require equipment, skills, and hard work to fix though. Here are 5 quick improvements anyone with a lathe like this can make, which I strongly recommend. Welcome to Adventures with a Very Small Lathe. The first is something every new lathe needs, a quick change tool post. I already did a full video on the tool post I fitted to this lathe, so go and watch that for full details. Quick summary, the sturdier the better, and make sure additional tool holders are affordable. The more tool holders you have, the better your life is. Number 2 is an upgrade to the tool post, which you can make whether you've already replaced it or are sticking with the original. Remove the handle or nut that holds the tool post down and put a thrust bearing onto the stud. Then fit the handle back over it so the bearing is squeezed between the handle and the tool post. The bearing will make sure the handle moves smoothly, allowing it to be tightened easily and consistently. It allows the tool post to be adjusted without having to be loosened too much, and it also reduces wear on the top of the tool post from repeated tightening. I used a needle roller bearing, but a ball bearing should work just as well. Small thrust bearings like this can be found really cheaply, and the quality doesn't matter much, so it's easy to try this out, and I'm sure you won't be disappointed. Number 3 can save your knuckles some pain. Most low-cost lathes of this type come with the handles attached by these ugly, bulky black cap screws. The cap head is in just the wrong place to catch when you're turning the handle, which slows machining down and can cause your knuckles to be bumped on every turn. Replace these screws with bright stainless round button screws for double benefit. Using the lathe becomes much smoother, plus the sleeker curved shape looks much better with the overall shape of the handle. Number 4 is a similar trick for the gib retaining screws. My lathes ship with cap head screws which are much too long for the job they're doing. They stick out and catch fingers and chips. I'm replacing them with shorter retaining screws with a bright stainless finish instead. There are 3 gibs in the lathe to be replaced. The compound slide gib, the cross slide gib, and the half nut gib under the apron. Number 5 is a fix for the huge backlash in the cross slide. This one caught me out and was a bit trickier than I expected, but you can learn from my mistakes. Most lathes have some backlash from the cross slide nut, but this is unrelated to that. It's due to slop in the mechanism which keeps the lead screw in place while the cross slide itself moves back and forth. Once these 2 screws are removed, we can see that the lead screw has a flange which fits into a pocket to keep it where it should be. The trouble is the pocket is quite a bit larger than the flange, so the flange slops around in the pocket. It should be possible to fix this with a correctly sized washer to fill up the extra space, leaving the flange just enough space to rotate freely. The inside of the pocket is die cast rather than machined. The depth measures at around 2.72mm with a micrometer kept clear of the outer edge. The inside of the pocket isn't perfectly shaped and there is quite a large radius on this inside corner, so the washer will have to take account of that. The flange itself is very close to 2mm thick, so the space that needs to be filled is around 0.7mm. I have been considering making a pair of washers, one either side of the flange, but now I know the dimensions are this small, I think making one single one to go into the bottom of the pocket makes more sense. The other side of the flange can slide against the flat surface on the end of the cross slide. I picked a piece of phosphor bronze to make the washer from, as it's a bearing material and should keep the lead screw turning while in firm contact. As I haven't turned this material before, my first attempt at a washer is a bit experimental. As usual, the first step is to clean up the face of the stock. To fit onto the lead screw, the washer will need a 10mm centre hole. Bronze doesn't really need cutting oil to drill, but the tailstock on the Proxxon isn't well aligned or very rigid, so I like to give the centre drill all the help it can get. A stubby solid carbide 10mm twist drill turned out to be perfect to bring the hole to full diameter. The washer only needs to be 0.7mm thick, so the hole needed very little depth. These solid carbide drills are my go-to for most lathe work now, but they're a lot more fragile and expensive than high-speed steel twist drills, so care is required. There's a lot of burr to be removed, but this can be done just as easily with a parting tool. To machine a washer with a known thickness, I'm planning to depend on the handle dial when moving the carriage. In order for this to work, both sides need to be cut with the same parting tool, and the width of the tool must be added to the travel. There's a problem with using this style of parting tool this way though. The sides of the parting tool are parallel, which means there's no relief along the side of the tool. Without relief, the side rubs against the face and gets pushed away. When the tool is parting, this isn't really a problem, as there are equal forces from each side. But when a tool is running along the face like this, it gets pushed away, causing a loss of precision. The face of the material is now as closely aligned with the edge of the parting tool as I can get it. Before I part off, I need to add a radius to take account of the shape of the corner of the pocket I talked about earlier. A long cut lathe file handles this pretty easily. To get the right thickness, I move the carriage 0.7mm using the dial scales, then another 1.45mm to allow for the width of the parting tool. The dials are pretty accurate, as long as the backlash has been taken up properly. I find bronze much easier to part than other materials on this lathe, especially with this narrow, freshly sharpened tool. The brass rod on the tailstock makes sure the washer doesn't fall down into the chips. Parts rarely get damaged by falling when they get parted off, but digging them out of a big pile of oily chips is just unpleasant. The washer looks okay, but is completely unusable. The twist drill cuts slightly undersize, so it won't fit onto the shaft, and I completely forgot to turn down the outer diameter, so it's way too large. The part is very delicate and it's impractical to try and fix it, so I'll start again with a new one. This time the first step after facing is to take the outer diameter down to about 14mm to fit into the pocket. A few more tenths of a millimetre, then a test fit. It fits, but is just a little too snug, so a light finishing pass should do it. Drilling works best if the RPM is kept very low while the front cutting edges are partially engaged. Too high and there'll be lots of noise and chatter. Once the full diameter of the hole is reached and the edges are fully engaged, you can hear it get smoother and quieter. Now I can increase the RPM to remove the material faster. I now know this drill is cutting a bit too small, so I used a reamer to bring the hole out to 10mm. I cleaned up the face and aligned the parting tool exactly the same way as before. As I know the hole is a snug fit on the shaft, I used a hand deburring tool to remove a tiny remaining inside burr. Only a very small radius is required, so I was more gentle with the file than I was with the first washer. The Kratex stick is a bit unnecessary though, as once the part is installed, no one will ever see this surface again. The thickness of the previous washer turned out just fine, so I used this exactly the same technique to set the thickness again. There's less material to cut through this time, so parting was even easier. I almost forgot to make sure I caught the part though. The slight angle on the end of the parting tool left this unwanted flange on the washer. Next time I'll try and make sure the blade has a slight angle in the other direction to get a clean part off. I've successfully removed material like this using a vise with hard square-edged jaws before, but in this case it was a little too heavy to slice off cleanly, and I had to tidy it up using a hand deburring tool. To remove the small remaining axial burr, I rubbed the faces on a bench stone, but this couldn't do anything about any burr remaining on the inside of the hole. To clean up the inside burr, I used the same reamer again, but this time by hand. The washer should be finished now, so the only thing left to do is install it and reassemble the saddle. It's a tidy snug fit over the diameter of the shaft. While this doesn't especially matter, it's satisfying to get it right. The shaft has a fairly large relief immediately next to the flange, so now that it's in place, the inner diameter of the washer doesn't matter so much. It took a moment to line everything up, but then the washer popped into place. It's immediately clear that there's no longer lots of slop in the pocket, but I'll need to reassemble before I can tell whether the fit's good. If the washer was a little oversized on thickness, I might have trouble getting this part to sit flush against the saddle, but there's no sign of that kind of problem. An oversized washer would also completely prevent the screw shaft from turning once everything was tightened. Everything looks good so far. The shaft still turns freely, but there's very little backlash movement. The final test will require the full handle assembly to try out. Now the slop's fixed, it should be possible to modify the scale to allow it to be adjusted and zeroed by hand. Another addition to the project list. There are one or two spots where the turning feels a little tighter, but nothing serious. The slop around the shaft is now so small that I can't feel it by hand or see it with the naked eye. This indicator shows 0.02 of a millimeter movement, which I'm really happy with. As I mentioned earlier on, making this washer got more involved than I was expecting, but I think it still counts as a really worthwhile quick fix. The other 4 changes are also well worth doing, and a couple are so simple and cheap they should be a pretty easy sell. Many thanks to those viewers who suggested some of these fixes in the comments, and others who pointed me towards other videos for inspiration. Sadly, I've completely lost track of where the ideas came from at this point, but I'm really grateful for the input. I'm currently working on fixing the fit between the saddle and the bed, as I think that's currently the biggest barrier to this being an effective lathe. The project's going well, but the video will take time to do properly, so thanks for your patience. Keep watching, I love you all.